Today we are going to solve a simple GCD problem. It arrived in Codeforces Round 1089 Division 2. The problem states that you are given two arrays A and B of length n. For each index of array A, you can perform the following operation at most once. Choose an arbitrary integer m such that m is between 1 to b of I, and set a of I to m, and it is masked that m is not equal to ai. Let the array after all the operations be a prime. You can only perform operation in such way that following condition holds: GCD of al to ar is a GCD of a dash l to a dash r. After changing the array, the GCD of a subarray must be equal to the GCD of the same subarray which was before changing the array. GCD of xy, greatest common divisor. We have to determine the maximum number of operations that can be performed while ensuring that the condition remains satisfied. Okay, what is said that let's discuss with an example. The example is, this case is 1 2 3 4 5 6 7. Okay, so if we transform this array to this 1 1 1 1 1 1 1, then if you choose any subarray, the GCD of this and GCD of this will be same. The GCD of 3 4 5 6 is equal to 1, and GCD of 4 1 is equal to 1. If you choose these two and these two, the GCD must be equal to same 1 1. So how many operation we did? 1, we changed 2 to 1, 3 to 1, and thus we changed 1 2 3 4 5 6. So the answer is 6. So how can we solve the problem? Let's suppose we have this array. First, let's just solve or think about the first and last index. For the first index, its GCD is taken with only to the right side elements. So if the GCD of a0 and a1 is less than a of 0, GCD of a0 a1 equal to x. If x is less than a of 0, then we can change the first element, because after changing the first element with the GCD of the first two elements, it does not change the value of the GCD of any subarray that have the first element. So we can change the first element with the GCD of a0 and a1 if x is less than a of 0 or first element. So then we will increase our counter. Same logic holds for the last index. We take last index, and if we take GCD with the second last index and the GCD is less than the last index, then we can change the last index to the GCD of last index and second last index. GCD of a of n minus 1 comma a n minus 2. If x is less than a n minus 1, we can easily change last index to x. It doesn't affect the GCD of any subarray. So we will again increase our counter. now the remaining elements which are between the first and last index. So for any index I, we have to make sure that the GCD of these three remain same after changing the index I. Okay, why this? Because we can take the ith index in any subarray like this, the subarray ending at I, or the subarray starting at I, or the ith index is in the middle means in between somewhere which is not last index or first index. So if we start a subarray with ith index, it will just become the condition for the first index. So we just need to check this I and I plus 1's GCD, and if the subarray ends in the ith index, we just need to, it's a case like the last index, we just need to check the I and I minus 1's GCD, and if it is somewhere between, then we need to check both of them. So just checking the three elements GCD is enough to ensure the whole subarray's GCD. So how can we ensure that after changing the ith index, the GCD of the three elements doesn't change? If we take left GCD, L GCD of A of I and A of I minus 1, and R GCD of A of I and A of I plus 1, and if we take the LCM of L and R, and if the LCM is less than A of I, we can change the value. How? Like we get L GCD from here, R GCD from here. If we convert I to LCM of R, then the GCD of 3 will remain the same, because then the A of I will contain both L and R. LCM will contain L and R, so the GCD of the triplet doesn't change. So if it holds, then we can change the ith index and we will increase our counter. So let's see the code. Test case in, then take the input n vector long, take the vectors a and b. Okay, the condition of the first index here, the condition of second last index is here, and for the index which are between the first and last, the GCD, the condition I said L, R and M. GCD of, I took the LCM like this. LCM of AB is A into B by GCD of AB, so L into R by GCD of LR. So if M is less than BA, then answer plus plus. Okay, this is the solution.